Unit 2. Instantaneous velocity. Instantaneous velocity. This is the block is placed on the surface. This is the final position, this is an initial position, this is the final position, and this is the velocity v, and it is the initial position, the initial point. This is a final point. Then it is the x direction, or you travel this box. And this is a x displacement, and it is also known as a distance. And there is a time interval t. It's a time taking. So average velocity. So average velocity is equal to v average is equal to displacement upon time taken. So v average is equal to x upon t. X is a total distance, and upon total time. So note down. This is a surface. The block is placed on this surface. This is a velocity. This is the initial point. This is a final point. And it is travel in the x direction. And taking a small strip on the for the checking point of the block, and take another strip, another checking point. Then will be measure the instantaneous point, and will be measure the instantaneous velocity on the instantaneous point. So we observe the velocity at checking point with t tends to 0 time. An instant is defined as the velocity at an instant is defined as the limit of the average velocity as the time t tends to 0. The velocity at an instant is defined as the limit of the average velocity as the time t tends to 0. So we can say velocity at instant point, yeah, velocity, instant velocity, then instantaneous velocity is equal to limit t tends to 0 x upon t, because the x upon t is the average velocity. So here x upon t is the average velocity, then v instant limit t tends to 0 x upon t is equal to dx by dt. So this is the instantaneous velocity. This is instantaneous velocity. Yeah, then the v instantaneous velocity is equal to limit t tends to 0 x upon t is equal to dx by dt. Dx by dt for the calculation of the numerical. Then instantaneous acceleration. Instantaneous acceleration. This is a surface, this is a block, and this is the final position of the block. This is an object. This is a There is the initial point, that is the final point, and this block is moved in the v1 velocity, and the final velocity is v2 of the block, and the a1 is the acceleration at the initial point, and the a2 is the acceleration of the final point, and the block is travel in the x direction. And t1 and t2 is the initial time and the final time of the block to travel in the x direction. So we can say at the point 1, velocity v1, acceleration a1, and taking time t1. At the point 2, velocity v2, acceleration is a2, and taking time t2. This block is moved in the x direction. So average velocity is equal to v2 minus v1, and average time is equal to t2 minus t1. At the final position to the initial position is the average velocity and average time. The block is moving in the x direction, that is between to the final point to the initial point is the average. Then we can take a point between point 1 and point 2. Then we can take a point between 1 and 2, then block. This is a checking point. Yeah, this is a instantaneous point. So we can say then that we can take a point between 1 and 2. This point is instantaneous point. At at the instantaneous point have instantaneous at the instantaneous point have instantaneous acceleration. Average acceleration. Average acceleration is equal to v. Average acceleration is equal to average velocity upon average time. So we can say A average is equal to v2 minus v1 upon t2 minus t1. So v2 minus v1 is the average velocity, t2 minus t1 is the average time. So we will denoted by the delta v upon delta t. That is the average acceleration. Then the acceleration at an instant is defined as the limit. The acceleration at instant is defined as the limit of the average acceleration. At the time delta t tends to 0. Please note it down. So we can say a acceleration instantaneous acceleration is equal to instantaneous acceleration is equal to limit delta t tends to 0 delta v upon delta t. This is known as a instantaneous acceleration. Del v upon del t for the use in calculation. So average acceleration taking a limit, then the is make a instantaneous acceleration. So acceleration may be positive, negative, and zero. Acceleration may be positive, negative, and zero. Position time graph. Position time graph. So this is a x, this is a t. x means displacement, t is a time, और जो ग्राफ बनेगा वो ऊपर की साइड बनेगा, यानी कि जो एक तरह से अपन बोल सकते हैं ग्राफ बनेगा वो ऊपर की साइड बनेगा. दिस इज अ पॉजिटिव एक्सेलरेशन and this is a displacement time and the graph is generated to the negative direction. So graph बनेगा नीचे की तरफ. This is a negative acceleration. यानी कि अपन कह सकते हैं जो ग्राफ बन रहा है the two side it is upper and this is a linear line in this graph, so is denoted the zero acceleration. Zero acceleration, yeah, we can say the constant velocity graph. So this line denoted to the constant velocity. Noted down.